Hello and welcome to the motor and transformer questions and answer video. We're going to be going through a lot of different questions, so to make it efficient, we will just be answering them for the most part. Complex questions will be explained in the beginning and some longer explanations will occur. Then after about a quarter way through the questions, I am then just going to be giving the answers and then briefly explaining things if need be. This will allow us to not form a headache over one question, but instead answer many questions which will occur in many different scenarios, as well as with different terminology, which will test how much we understand this topic. The product of this is a studying method that is going to work with how our brain naturally works. With more experience, things begin to make sense. In real life, we don't always have the ability to spend time dissecting every single topic that we don't understand, but as time goes on, experience with these topics allow one to connect more dots and make sense of things. If you're confused about any of the questions or answers, feel free to leave your question in the comments and I will answer it to the best of my ability. Okay, so beginning on the first question, a service demands alternating intervals of load and no load, load and rest, load, no load, and rest. This is called what duty? And this would be known as intermittent duty. Okay, the next question, what is the factor that indicates the maximum size fuse able to be used in a branch circuit containing no motors? And that indicating factor would be the load. Okay, moving on to the next question, you see we're going at a good pace here. What is the problem if in a Edison 3-wire system, some light bulbs are dimmer than others, which are brighter? And this would be a poor neutral connection. Edison 3-wire system simply means a single phase 120/240 volt system with a center tap, also known as split phase electric power or single phase 3-wire system. Unlike 3-phase, the lines of a single phase 3-wire system are not 120 degrees out of phase, but instead 180 degrees out of phase. When thinking of a sine wave, we can understand all this means is that the two lines, also known as phase A and B, are merely equal and opposite at any time with equal magnitude to the other phase. This means that when one side is pulling, the other side is pushing, or in other words, when one side is negative, the other side is positive. This is the same thing as a battery where you have positive and negative terminals. These are 180 degrees out of phase of one another. In any moment of time, current is flowing in one direction. Because of this, the magnetic lines of flux have a specific polarity. This drives a current in the secondary in a certain direction, creating a positive potential on one side and a negative on the other. In the next part of the cycle, the polarity changes. So the negative becomes positive and the positive becomes negative. When one wire is positive, the other one is negative and vice versa. There's a lot of discussion and debate on this topic. Some claim that 180 degrees out of phase is merely a convenient way of expressing the polarity difference, where when one side is positive, the other side is negative, and that the sine waves are not actually 180 degrees out of phase. Okay, next question. You see I threw a few in here that are important. They may indirectly have to do with motors or transformers, or they may just be so important that I thought it would be a good idea to throw them in here. There's not too many of these, so most of them will be motors and transformers. Okay, so this question asks, the greatest danger when accidentally contacting a live conductor is the blank. And that would be the contact resistance. Okay, so what are you touching? Are you properly protected? Do you have proper insulation like in the rubber of your shoes to where that is insulating you from what they would call the ground? Or something bad like you're leaning over a metal oven and your belly's touching the oven and you accidentally are touching a live wire above your head and the electricity goes through your heart, through your belly. Or you're holding something metal with one hand and you touch it with the other hand, it's going straight through your heart. And depending on where electricity travels through actually affects the resistance, but it's good to just avoid getting electrocuted at all. Okay, so remember, good insulation, and if the boss is nagging you to hurry up and it's dangerous, then go work for someone else. Next question, what will cause a dual voltage motor to run more efficiently? And that would be higher voltage. Next, does a transformer run more efficiently when the load has a low, medium, average, or high power factor? And that would be a high power factor. Power factor in an AC system refers to the ratio of real power absorbed by the load to the apparent power that is flowing in the circuit. Power factor is often explained with a glass of beer. There's many pictures and also a video of this on YouTube. I will link that in the description, but this is pretty easy to comprehend. So The full glass, including the foam, is the apparent power. It's like the apparent beer. The bartender hands you some beer, and hopefully it doesn't have a bunch of foam at the top. No matter what it is, that's your apparent beer that you have. The foam would be known as the reactive power. This is going to be useless. Okay, so that's kVAR. R stands for reactive or reactance. The actual beer without the foam is the true or real power. So it's like the true or real amount of beer that you actually have. This would be in kilowatts. This is actually used by the load. So that's why things are rated in kilovolt amps, because it's saying, okay, we need this much power. But depending on the source of power is going to depend on how much true or real power there is and how much reactive power there is. There's also something where there's a power triangle and power factor formulas, but that's going to be for a whole nother video. High power factor indicates that the power supplied to the load is used efficiently. So just think high power factor, that's what you want, and that's because it's a ratio of the real power absorbed by the load to the apparent power that's floating around the circuit. So in that case, of course, you want a high power factor if you want things to be working correctly. A load with a low power factor does not consume the incoming electric supply efficiently and results in loss of electricity. DC circuits have no power factor due to zero frequency. In DC systems, the current and voltage are always in phase. In other words, the difference in phase between the current and voltage is 0 degrees. Furthermore, the cosine of 0 is 1. To sum it up, the power factor in a DC circuit is 1 every time and never anything else. Next, to measure the power factor of a load, what type of meter or meters would you use? And this would be an ammeter, voltmeter, and wattmeter. Next, in order to balance an unbalanced three-phase system, one would make all of the loads equal to the blank single-phase load, and this would be the largest single-phase load. Next, in a DC shunt motor, what is the reason for using a rheostat in the field of the DC circuit? And when you know what a rheostat is and you know DC circuits, you know this would be to control the speed of the motor. A rheostat is simply a variable resistor that is used to control the flow of electricity by changing the amount of resistance. This is similar to a potentiometer, so it's good to know the difference between a rheostat and a potentiometer. There are videos that explain it perfectly that are only a minute or two long on YouTube. I'll also link one or two of those down below in the description. Okay, next we have a true or false. Squirrel cage induction motors have no commutator or slip rings. And this is true. Next question we have one we're actually going to have to solve for. The primary voltage of a transformer has 115 volts applied. What is the secondary peak voltage if the transformer has a turns ratio of 4:1? Okay, so the first thing we need to do is think about that 4:1 ratio. We have 115 volts in. It's 4:1, so we can think about it like it's a step-down transformer. The secondary has less turns than the primary. But we're working with 4:1, so all we got to think is 115 divided by 4. And when we do that, we get 28.75. But now we're not thinking the effective value or the root mean square value. We are thinking the peak value, the peak voltage. Okay, so to get peak voltage, you can see up right below the answer, I have the formula for that. Some people call it VP, so it's not voltage primary, it's the peak voltage. The formula for this is the square root of 2 times the root mean square voltage, and the square root of 2, we're thinking a rounded version. 1.41 is the number that we use. We times that by the root mean square. I also included the other peak voltage formula that uses the average voltage, but here we're just looking at the voltage that they're giving us that would be measured, so that would be the effective voltage or the root mean square voltage. Those two are the same things. So it's pretty simple. Let's take the formula. We're going to plug in that effective value, that root mean square value, which is 28.75. That's what would be measured on the secondary, but we want to know what is the secondary peak voltage. Okay, so to find out that peak voltage, we do times 1.414, and we get 40.6525. We're looking for 40.66, so we can see that we're basically dead on to that. Now if we work backwards, this shows that 40.66 divided by 28.75 equals 1.414260887. So you can see how 1.41 is a rounded version of this. The conclusion is use the peak voltage formula of the voltage that you have times 1.414. Next question. A metal bar that is made from iron or steel that is placed across the opposite poles of a permanent magnet in order to help preserve the magnetic field by completing the magnetic circuit. What is this? And this would be called a magnetic keeper. You'll see a lot of people that are storing magnets do this. If you have a horseshoe magnet, that would be a simple piece of metal that's just flat, and then the north and the south pole are just going to be touching that at the same time. So that's how you'd have a magnetic keeper on something like a horseshoe magnet. Oftentimes when people are storing magnets that have north and south poles that are like a bar magnet, where you have the opposite ends that have the opposite polarities, people store them with the opposite polarities stacked on top of each other. So let's say you have the same size bar magnets and you have north and south going up and down, then you'd have south and north going up and down, north and south and north, north and south, and you'd just stack them opposite on top of each other, because then they would share the same magnetic field and it would help keep the magnetism of that magnet. Next question, what force tends to set up the magnetic flux in a magnet? And this would be known as magnetomotive force. You might know electromotive force. Here we have magnetomotive force. Next, how many single-phase transformers need to be interconnected if there is a transformer bank that is using an open delta connection? Okay, that would be 2 single-phase transformers. An open delta is going to be for a whole video on its own, so you see my note, make a video about this. Look out for that one. Okay, this next one's kind of one of those ridiculous ones. What is the load in a circuit used for? And that is to utilize the energy. Okay, so that is one way of explaining it. Next question, how does phase voltage compare to line voltage in an open delta connection? So it's delta connection, phase volts equal line volts. Phase volts equal line volts whether you have an open delta connection or you just have a delta connection or configuration. Okay, next, in a scenario where a motor runs when a push button is pressed, but will stop when the push button is released, this action is known as, and this would be known as inching. Next, when a regular 2-winding transformer is connected to an auto transformer, why does the kilovolt amp rating of the 2-winding transformer increase? And this is because the energy is transferred inductively and conductively. Next, if a low ohm reading is shown when a megometer, is connected to the ends of a motor winding, what does this mean? Okay, and this one's really simple. So before I give you the answer, let's at least think about this one. You have your motor winding, you see that it has a low resistance. Okay, so if you had a high resistance, you obviously don't want that. So if it has a low resistance, what does it mean? And this would mean continuity. And this might make more sense in real life because you'd see a really low number and you think, okay, so there's continuity because there's a very low resistance. Okay, and then you see where I say meg ohm meter. So a lot of times this device is called a megger or megger. It's MEGGER, and it's simply just an abbreviation for a meg ohm meter. Next question. When a single phase induction motor has its starting winding disconnected from the supply, it will continue to run on only what winding? And this would be the rotor. Next, what is developed in the armature of a DC generator? And this is alternating current, AC. Next, what is the main purpose of using thermal overloads for the protection of 3-phase motors? And this would be to protect the motor in case of a sustained overload. Next, if a step-down transformer with a 5-to-1 turns ratio has a varying voltage of 105 and 125 volts, what is the maximum secondary peak voltage? And here we're working with a few things. We have that varying voltage, and then the question is asking for the maximum secondary peak voltage. So not only the maximum secondary, but also the maximum secondary peak. So there's 2 things kind of hidden in there. So first we need to think about the maximum secondary voltage, and that would be 125 volts. We know we have that 5-to-1 turns ratio, so we just think 125 divided by 5. When we do this, we get 25 volts on the secondary. And again, to do that peak voltage, the formula is 1.41 times that root mean square voltage. So here we do 1.41 times 25, we get 35.35. And the answer is just looking for 35 volts. So you see, we're very close to that. and it's just a rounded version of that. If you want to figure out the turns ratio and these formulas, look at my turns ratio video that I posted before this. You can also see I showed the formulas for how I actually solved this. I explained it a little simpler because this is kind of a simple question, but I show the turns in the primary over the turns in the secondary, and I could do an equal sign in the middle of that because that is actually equal to the primary voltage over the secondary voltage. So we don't have the secondary voltage, so I plugged in the numbers. We have 5 turns in the primary over 1 turn in the secondary. That is equal to 125 volts in the primary over the secondary voltage that we don't know, so that's the variable, the ES. My turns ratio video explains this part, but looking at those ratios, if we do what I called the butterfly method, or in simple terms, if we take the top and bottom of the first number and we multiply it by the opposite of the next number, so we take the top number of this, multiply by the bottom of the next one, bottom of this by the top of the next one. Then we get the formula C below this. 5 turns in the primary times the secondary voltage. This is equal to 1 turn in the secondary times the primary voltage, 125 volts. So the numbers we can multiply are 1 times 125. We get 125, then we get 5 turns in the primary, and we times that by the voltage in the secondary. This shows us that the voltage in the secondary is equal to the 125 volts in the primary divided by the 5 turns in the primary, and we get 25 volts in the secondary. Then we do the whole thing for the peak voltage after that. So you can see where I explain this a lot simpler. So as you can see, since I already understood it, I just took 125 volts, my maximum voltage, and I just divided that by 5 turns. I didn't think about formulas or anything like that. I was just understanding how transformers and the turn ratios work and how everything affects each other. Okay, so it's a lot better just to understand it than to memorize all the formulas. But it's also good to know the formulas, of course. Okay, this next one might be a little more relieving now. What is the force between 2 electrically charged objects? Okay, and think about when you're rubbing your shoes on the carpet. Okay, what is that force? And that is electrostatic force, or a lot of people just call static energy static force, but in fact it is electrostatic. Next, why are transformers rated in kilovolt amps instead of kilowatts? Kind of got a brief look at this earlier, and this is because the loss depends on the volt amps. Remember the power factor? Explain with the beer. Make sure to watch that video that I'm going to link in the description about that. Next, which of these provides the highest operating efficiency? Transformer, motor, converter, or generator? And this would be a transformer. Next, what is most likely the cause if a motor fails to stop even when the push button is pressed? And this is the interlock has been welded. Next, what type of contact is a maintaining contact in motor controls? This would be called a normally open contact. Next, the only time that a repulsion start induction run single-phase motor actually runs as induction is when, and this is when commutator segments are short-circuited. Next, what does the rotor flux do when the armature flux of an alternator is at its leading power factor? The armature flux of an alternator aids the rotor flux. Next, any switch or device that in normal circumstances is used to stop and start a motor by making and breaking the circuit current of the motor is known as, and this is simply known as a controller. Next, what is not affected by the overcurrent in transformers? And this would be the breather effectiveness. Next, what is the name commonly given to auto transformers that serve the purpose to start large induction motors? And this would be known as a compensator. Okay, next we have a little bit of mental solving here. What would happen if in a circuit you decide to cut the resistance in half while doubling the voltage? So that basically explains itself, and that would be 4 times as great. Next, what happens if someone decides to switch on a stationary 3-phase induction motor with one of the phases disconnected? Unless the power is immediately disconnected, the motor is potentially going to burn out, and it's going to burn out fast. Next, when thinking of pros and cons of DC versus AC motors, what would be one of the best pros of using a DC motor instead of an AC motor? And this would be the DC motor has better speed control. Next, what is the actual unit for electrical charge? And this is known as the coulomb. Next, how much resistance does a coil have when it's open? So again, it's pretty self-explanatory. And this would be infinite resistance. And also on the other hand, you'd have zero inductance. Next, in what kind of motor does the rotor and stator fields rotate with the same speed? And this is in the name, this is a synchronous motor. Next, what will happen to a circuit if the starting winding of a single-phase induction motor is left in? This will cause the unit to draw excessive amounts of current, which will lead to overheating. Next, within a specified period of time, what type of load is the maximum load that is produced or consumed by a unit or group of units? Okay, and this is the peak load. The maximum load could be potentially if the source has a fluctuating amount of voltage or power going in, because remember, there's the same amount of power on the primary and secondary of a transformer. You're just either changing the voltage or the current up or down. And of course, when you're making the voltage go up, the current's going down, and vice versa. So the power's still staying the same. So just making sense of this a little more, when it's asking about that maximum load, we know that that would be a peak load, because it's not asking about anything saying there's a fluctuating amount of power coming in or anything like that. Okay, so we can make sense of these things. Some of them are basically just kind of ridiculous, but it's good to just answer a bunch of these. And then we'll be thinking about motors and transformers a whole lot by the end of this. Next, what should happen to the leads of an ammeter when it's disconnected from a current transformer? And the leads should be shorted. Next, in a circumstance where an electrician is working on live 600 volt equipment that poses the risk of damaging rubber gloves, what should the electrician do? Okay, and the answer, of course, is to call in sick. Just kidding. You should wear leather gloves over the rubber gloves. But in all seriousness, remember, your life is very important. You should value your life over anything, even a lot of money. Okay, next, in a three-phase motor with an ABC phase sequence, what is the sequence of the current rotation? Now, that's kind of an interesting one, and this would be BCA. Next, what is the drawback of using an auto transformer? And this would be between the primary and secondary lacks isolation. Next, what kind of motor is one with a wide range of speed? Okay, wide range of speed, this is a DC motor. Next, in degrees Celsius, what is the ambient temperature in motors where the horsepower rating of motors are founded on an observable safe temperature rise above the ambient temperature? And okay, try to think about this without looking in your code book or anything. The answer is 40 degrees Celsius. Next, how many electrical degrees apart are the legs of a three-phase circuit? And this is 120 degrees apart. If the 120 degrees thing doesn't make sense to you, just think of a circle, you get 360 degrees, and if you think of a third of that, you have 120 degrees. So 120 times 3 is 360. It's just a third of 360 degrees. So I'm going to try to do this my best with highlighters. Okay, so this is why it's 120 electrical degrees apart. Because if you have a spinning magnet going to three different, let's say, conductors here, and they're 120 electrical degrees apart, and they're placed here in this shape, we'd notice that if we're thinking about a circle, then since this is split up in three different sections, these are 120 degrees apart. Okay, so you have a magnet in the middle of the spinning, and when the tip of the magnet gets closest to any one of these conductors, that's the peak of its voltage. Okay, so you have the sine wave going at its peak when it touches this one, sine wave going at its peak when it goes to this one, sine wave going at its peak when it goes to this one, and that's the nature of a three-phase system. That was kind of a ridiculous explanation. I'll link a better explanation down below, but it's good to actually visualize things and to take it to a step where you're thinking, okay, it's 120 electrical degrees apart. That's why everything's out of phase. That's why you have a three-phase system. It's having to do with how the current is induced in each of the coils of the three-phase system. Again, it's good to just understand these things, because then you have questions about them, you really don't have to think twice about it. Next, on a basic level, how does a generator work? So what I was explaining a second ago was literally explaining the generation process of a three-phase system. So you could either have a magnet spinning by conductors, or you could think of it like conductors spinning around a magnet. You could also think of it like a magnet moving through a conductor. There's kind of some different perspectives to look at it and some different things that could happen in the generation process. But here we go with the answer. On a basic level, a conductor is moving inside a magnetic field. And for an interesting read, go to Moving Magnet and Conductor Problem on Wikipedia. Next, how much time does it take to travel travel 90 degrees in a 60 cycle AC system. Now, if you understand sine waves, or if you saw my sine waves question and answers video, then this will be no problem. Okay, so to first think about it, we have a 60 cycle AC system. So we know that in 1 second, we have 60 cycles. We could also say that if we have 1 cycle, then we'd have 1/60th of a second. Okay, and since 1 cycle is 360 degrees, then that is the same as saying 360 degrees, 1 cycle, is 1/60th of a second. Okay, so now if we think about that and we think 90 degrees of 360 degrees, we could think that now instead of having 1/60th of a second, now we have 1/240th of a second. Okay, so here's that answer and here's it solved out now. So now you can actually look at that. In the video, I explain the 2 different methods of solving this, where I have the first method of solving it and then I say or. So if you want something 4 times smaller, obviously you could just divide it by 4. Okay, so if you're curious about that, if you don't know how to do it, check out that video. Next, what is the unit that describes electrical work? And this would be money. Just kidding. This is the watt-hour. Next, why is the core of a power transformer laminated? And this keeps eddy current loss at a minimum. Next, a single throw switch is mounted in a way so that when the switch is to be opened, the blade must move in what direction? And this will be downward. Next, what unit, identified in ohms, expresses the total opposition of current flow in an AC circuit? Okay, and you definitely got to think twice about this one. You have the total opposition of current. Okay, and this would be impedance with the symbol Z, made up of 2 components, the ohmic resistance and reactance. This is usually expressed as the formula Z, impedance, equals R plus IX. R is the ohmic resistance, X is the reactance. So because it's asking the total opposition of current flow in a circuit, we know that this is impedance, just simply like that. We don't have to understand too much other than that. But we can also understand that resistance is not the total opposition, but it is instead a measurement of the opposition of current flow in a circuit when voltage is applied. Okay, and as we see, that is a part of the 2 parts that make up impedance. Next, what type of motors do not contain a commutator? And this would be squirrel cage motors. Next, how many degrees apart will the line voltage be if the phase voltages are 120 degrees apart? And they would be 120 degrees apart as well. Next, what instrument is going to be the least practical when indicating if an overloaded generator is going to overheat? The least practical would be a voltmeter. When thinking of pros and cons, what would be a pro of using 240 volts versus 120 volts for a load with the same wattage? This would be less voltage drop. Okay, next, what would you do in order to reverse the rotation of a 3-phase motor? And if you saw my 3-phase systems explained video, you'll know this is just you reverse any of the 2 leads. Next, what should be used to fit new brushes to the commutator in a generator? And you simply use a strip of sandpaper. Next, both wound rotor and squirrel cage motors are what type of motors? Okay, and if you look up these 2 types of motors in the code book, you'll see that they are both induction motors. Next, when dealing with a current transformer, which coil will have more current? Now this one might seem kind of ridiculous because you might think, oh, a current transformer, it's probably going to give you more current, right? Well, no. The primary of a current transformer has more current, which obviously means the secondary has less current. Next, what kind of transformer has only 1 single winding? And that is an auto transformer. Next, when using a multiple motor circuit, you have protection on the feeder, branch circuit, and the motor. In the circumstance that the feeder trips, what would most likely be the cause? And the feeder would most likely be the cause. Next, in a 240 volt system with a center tap, the 2 lines face A and B in the neutral. Why should each conductor not be placed in 3 separate raceways? And this would have to do with inductance. Next, what kind of generator is used for electroplating? This is a separately excited generator. Next, the current of 3-phase systems are usually how many degrees out of phase? And as you might guess, they are 120 degrees out of phase. Next, in a DC motor, the armature current is proportional to, that would be the voltage applied. Next, for the most part, every electric motor works on the forces of repulsion or induction. Next, Normally speaking, what is the ambient temperature allowed for operating Class B motors? That is 40 degrees Celsius. Next, what is the size difference of a three-phase motor versus a single-phase motor of the same rating? And that would be the three-phase motor is less than the single-phase motor in size. And my three-phase systems video explains this as well. Next, why are carbon brushes used on the commutator? And this is because they serve to both lubricate and polish. Next, where are DC motors applicable? This is where a high starting torque is needed. Next, what is the relationship of volts per turn of the primary and secondary coils of a transformer? That is, the primary is the same as the secondary. Next, a three-phase, four-wire connected system has 277 volts for lighting. What would the operating voltage be? And we see that this is 480 volts. This is because this is a Y-connected system. This means that the voltage changes from the line and phase. The line is always going to be bigger than the phase. So when they're asking about the operating voltage, we're going to think that 277 volts that we're using for lighting, and we're going to multiply it by the square root of 3. The number we're using is 1.73. And we get 479, so when you're thinking about voltage, you could see, okay, that's 480 volts. Next, what expresses the relationship between the primary and secondary coils of a transformer? That would be the turns ratio, like a 2-to-1 turns ratio. Next, a three-phase transformer is connected delta Y with 480 volts primary and 208/120 volts on the secondary. What is the relationship to the line voltage on the secondary to the phase voltage on the secondary? Okay, so we're thinking delta Y. So we have delta as our primary, we have the Y as our secondary. Because the Y is the secondary, we know that voltage is going to be changing while the current actually remains the same. And because of this, the line voltage on the secondary is going to be more than the phase voltage on the secondary, since this is going to be a Y configuration. And we see the answer is greater than the phase voltage. So the answer is greater than the phase voltage. Of course, this could have said 1.73 times greater than the phase voltage, but it's just asking simply here. Next, a three-phase transformer is connected delta Y with 480/208/120 volt. What is the relationship to the line current in the secondary to the phase current in the secondary? Okay, so we're working with another delta Y, and we have the same ratings, but now it's different. It shows it as 480/208/120. So this is showing that you have 480 on the primary, and then on the secondary you have 208 or 120, depending on how you wire it. And of course this makes sense when we think about a Y configuration, and also thinking about the Y configuration where the question is asking the line current on the secondary and the phase current in the secondary. Since again our secondary is the Y, then we know that the current is equal in the phase and the line. This is explained in depth in my three-phase systems explained video. Next, how many hot conductors can use a common neutral when using a 4-wire 3-phase delta system? And this would be 2. Next, how is the speed of a DC motor controlled? This is done by keeping the armature held constant while varying the field current. Next, if a 3-phase delta Y connected transformer is considered to be 100% efficient with resistive type loads, then what is the relationship to the maximum kilovolt amp of the load to the primary and secondary? The relationship would be the kilovolt amp of the primary and secondary are equal to the maximum kilovolt amp of the load. Next, what percent would the efficiency of a transformer most likely be? And the answer could be anywhere from 90%, it could be 90s, or it could be in the upper 90s as well. Look for something in the 90s or just 90%. Next, 3 single-phase transformers are wired together so that the line current is equal to the phase current. This wiring configuration would be known as, okay, and I didn't explain this on any of the other ones, but it's good to really just kind of blank out all the BS that they're giving you and kind of look at one simple thing and take it from there. So they're saying line current is equal to the phase current. What wiring configuration is that? And of course that would be a Y configuration. Next, when materials that retain large amounts of magnetization after the force that was magnetizing it is removed in an iron core transformer, blank losses occur? And this would be hysteresis losses occur. Next, what is a transformer's association to DC and AC? And the answer is transformers only work on AC. So this is one of those ones to where if you just understand generators work, transformers work, and all this stuff kind of works, it's kind of just a no-brainer. Oh yeah, you're not going to have DC in a transformer. It's also one of the main first things they tell you when you're learning about transformers. So instead of just memorizing the answer to these questions, the best way is just to really research the topics and understand them. Next, the core of a transformer is made up of what materials? And this would be steel only. Okay, so no copper or anything like that. So they're talking about the actual complete core. Obviously, when you're thinking about like the core of the Earth, you're not going to think about what's surrounding it and what's in the core. You're just thinking about the very, very core. Next, a plant has an ungrounded 480 volt three-phase system equipped with 3 ground detection lights. 2 out of the 3 lamps are bright, and phase B's lamp is dim. Where is the ground fault? Okay, now don't think about this one too hard or anything like that. That would be the B phase. So in a 3-phase system, everything is connected in a way, but it's still sort of functioning in its own isolated system in a way as well, each of the phases. Next, what is the percentage of voltage drop in this scenario? 120 volts from the source and 115 volts at the destination. Of course, an easy way to think about percent, and I guess kind of a very basic way of explaining this is, okay, you'd get the smaller number and you're going to divide it from the whole number. But we're not looking for 115 volts versus 120 volts. We're looking at the percentage of voltage drop. Okay, so there's not 115 volts of voltage drop with the difference of 120 and 115. There's only the 5 volts of voltage drop. So when we want to find out the percentage, we're going to divide from that difference, not the 115, okay? So we're going to divide 5 divided by 120. When we do this, we get the number 0.0416 repeating. So if we want to round that as a percentage, then we could just do 4.17%. Or if it just asks 4%, then it could just be that. Okay, and we see if we did 115 divided by 120, then we'd get 0.958. So then we'd have to figure out the difference from 100% with that. Okay, so it's easier just to get the actual answer from your first calculation. Okay, next, describe the symbol for a thermal overload in a motor control wiring diagram. Okay, and it basically just looks like 2 question marks turned sideways. But if you want to get really specific, you could say it's 2 question marks turned 90 degrees in an opposite fashion inward. Because if you think about it, you get 2 question marks, and like I was saying, you just turn them inward. I guess it's a simpler kind of way of saying it. Just do 90 degrees, and you take off the dot at the end of the question mark. That looks just like a thermal overload symbol. Next, what instrument would you use to measure the RPM of a motor? This would be a tachometer. Next, what instrument is used to identify the phase relationships between the voltage and current of a 3-phase AC circuit? This would be known as a power factor meter. Next, when is an autotransformer used instead of an isolation transformer? This would be where the ratio of transformation is low. Next, why would one use 2 watt meters to measure power of a system? And this would be if it is a 3-phase system. Next, what would you use to increase the range on a DC ammeter? You would use a shunt. Next, the function of a motor can be understood through the principles of, and on the very foundational level, we could think magnetism. Next, what can be used to control the current running through a DC arc lamp? Okay, so all we got to think is, how are we going to change the current in this DC circuit? And that would be using a rheostat. Next, what are the specs on a 4-wire 3-phase system with 208/120 volts? Okay, so if we wire this 3-phase, we can have 208 volts. We can also wire single phase with 120 volts if we just do one of the phases with the center tap, and then we can also do single phase 208 volts. And this would technically be phase A and B with the center tap as well, but in some cases you do not need the center tap and you just have the phase A and phase B line, or line A and line B. Next, what instrument would you use to find the ungrounded conductor in a single phase system? This would be a neon tester. Next, how much heat will be produced from a 240 volt heater ran on 120 volts, and that would be a quarter as much. Next, what is the most common way to improve the commutation of a DC generator? And this would be the interpoles. Next, what type of configuration allows the use of both single phase and three phase as well as two voltage levels? And this would be known as a three-phase 4-wire configuration. Next, in a wiring system, the location where current is taken to supply the utilization of equipment is known as, and don't think about this one too much, this one is kind of ridiculous. This is known as an outlet. Next, what is the name for a protective device that protects the motor against becoming dangerously overheated caused by overload and failure to start? This would be called a thermal protector. Next, what does the horsepower rating of a motor indicate? And this is the output of the motor. Next, how many meter or meters would be the minimum amount able to measure power in a three-phase system? The answer would be 1 watt meter. Next, why is it usually not good practice to supply lighting as well as motors on the same circuit? Okay, and we have multiple reasons. 1, for satisfactory service, lamps must operate within closer voltage limits than motors. 2, short circuits as well as overloads are much more common in circuits for motors. 3, the large starting current when starting a motor causes a voltage drop on the circuit which will cause the lights to dim or blink. Next, do transformer supply fire pumps need secondary overcurrent protection? And the answer for this is no. And that's the last question. So if you're keeping track of like a score, let me know how you did in the comments below. Again, if you're confused about anything, if you have any questions, put that in the comments. I'll try to answer it to my best ability. Maybe someone else will answer it too. If you want to see more videos on electrical, stuff towards electrical engineering, and stuff towards becoming a journeyman electrician, master electrician, subscribe to see more videos. There's going to be a lot of content leading towards that and based around that. And of course, if you enjoyed the video, give it a thumbs up. This will help other people see it. And until next time, take care. Goodbye.